In section 1.6, we're looking at comparing measurements for precision. So we're really going to be talking about what's more precise, and what's more accurate, and our vocabulary is going to be about precision and about significant digits. And you may find when we get to the significant digits, it can be a little confusing. So pay close attention when we get to that section. So when we're talking about precision of measurements, the finer things are being defined, the more precise they are. And in this particular example, we're taking a look at watches. And you see Noah's watch has only 4 demarcations on the watch, so every 15 minutes. And you're left basically to sort of estimate what exact time it is. And we compare that to a digital watch, it's getting all the way down to the second very precisely. So in this case, we've got to say that Mia's watch is much, much more precise than Noah's watch, which says, it basically only shows 0, 15 minutes, 30 minutes, and 45 minutes in terms of being truly accurate. So precision is the level of detail that the instrument can actually measure, and or it's the measurement that we have chosen to collect. Okay, so if we have a ruler that's marked in millimeters, that's more precise than one that only goes down to centimeters, because the millimeter is a smaller unit, and consequently we can get a more precise measurement. So if we want to just compare these particular measurements to see which one is more precise, 71 inches is more precise than 90 feet because inches is a smaller unit of measure. Similarly, and yet different, these are both measured in yards, but here we've gone to tenths of yards, whereas the 36 yards has only been measured to whole yards. So because we've gone to a finer portion of the yard and gone into decimals, this one is more precise than that one is. So when we talk about significant digits, we're talking about looking at all the non-zero digits. So you're looking at, if we're looking at the number 281.39, it has 5 significant digits. So it's got 5 non-zero digits. Okay, so zeros are to the right of both the non-zero digit, zeros that are to the right of the non-zero digit and the last non-zero digit and the decimal point. Okay, so in this case, 70 is the part that we're considering significant, so it's 2 digits. So now these zeros don't count, but this 0 does, and that's because it's to the right of this non-zero digit that is to the right of the decimal point. Okay, and here zeros that are between significant digits also count. So 500.7, all 4 digits count in this particular case. Okay, zeros at the end of whole numbers are usually assumed to be non-significant. For 220 centimeters, now this 0 is not between numbers. It has only 2 significant digits, whereas 202 centimeters, where this 0 is between 2 whole numbers, that has 3 significant digits. Okay, so it's a little tricky, and so you want to be very careful when you're taking a look at that. So let's take a look at the number of significant digits in the measurement. So now this 0, right? The 1 is significant. The 2 is significant. This 0 is significant because it's between those 2. But this one is not because it's at the end of the number if it's off to the right. So this has only 3. In this particular case, the 1 is significant, but these are both off to the right, so they are not significant. This one has only 1. And in this case, 1, 2, 3, all 4 of these are significant. Okay, so hopefully that makes it pretty clear as we do work in class. It should help also to solidify your understanding of significant digits. When you're performing calculations involving measurements, so this is often people ask, well, how many digit should I go to in a problem? And so there are some basic rules around which digits you're considering significant and things that you can default to so you don't have to wonder, how should I give this answer? Okay, so when we're talking about addition and subtraction, you want to round your sum or difference to the same place as the last significant digit of the least precise measurement. Oops, excuse me. Wanted the highlighter of the least precise measurement. So you can see 7.3 is less precise than 3.24. It has tenths, so we're going to round to tenths. Okay, so you're rounding to the least precise measurement. When you're talking about multiplication and division, the product or quotient must have the same number of significant digits as the least precise measurement. And again, the least precise measurement. You see, they have that in common. So 40 has only one significant digit. 31 has two significant digits. When we multiply them together and get 1240, that's got three significant digits, but we're supposed to get it back down to one, so you only go to 1000. Okay, in practical application, I don't see a lot of things. I don't see 1240 being rounded back down to 1000 very often. But when we're talking about significant digits, it's important that you understand what is meant by that. Okay, and if we want to calculate with significant digits, here we're looking at one significant digit and three significant digits. Our answer will be in one significant digit. So when we multiply it together, I'll have 0.6, 89.6, but we want to have only one significant digit. This is going to round to 90. Okay? And when we're talking here, we have two significant digits and two significant digits. When we multiply them together, we want to give our answer with two significant digits. So let's go ahead and pull out a calculator to do that. 0.043 times 0.22, 0.00946. So we're only going to we're going to round from 946 to 95. That's two significant digits. Okay, so what was important there is two significant digits, one significant digit. Okay, and that's really what we have to talk about with significant digits.